Let's start recording. Okay, thank you. So welcome everybody to this new series of this new webinar, which is part of the sessions provided by the European Open Source Academy. In this case, the topic is focused on open source and more specifically open source hardware ecosystem. The webinar will be 1 hour long. We will have discussion with our speakers. Thank you very much to all of them for joining us today. And of course, everyone is welcome to join us to the conversation. So every time you want to ask a question, please feel free to add a question in the chat, and we will try to tackle it during the conversation or just at the end, okay, depending on the topic itself. So moving back to our speakers, again, thank you very much for coming. We have, by the way, my name is Teresa Cervero. I'll be the moderator of this panel. I'm working at the BSc and I'm involved in the RISC-V ecosystem. And at BSc, we develop hardware and we contribute to the open source community in hardware and in software, but very focused on high performance computing. And today we have with us different organizations. And I think it's very nice because we might have a broad view of what open source hardware means and different pieces of the ecosystem, and we will get different perspective, which I think that might provide a very rich conversation. So I will let each of the speakers introduce themselves first, and then we can jump into the conversation. If you don't mind, I will use the order that I have here on my screen. So Andrea, you will be the first.
Hello, everyone. I'm Andrea Gallo. I'm CEO at RISC-V International. And RISC-V is an open industry standard. So we are very keen on all possible collaborations with industries and academia and all possible different models of engagement. And I'm sure we will have the opportunity of describing those in this webinar. So thank you for inviting me.
And Andy?
Hi there, I'm Andy Moore. I am the Director of Marketing at RISC-V.
We cannot hear you.
Yeah, I could hear Andy.
Yeah. Can you hear me okay?
Yeah. Yes.
Okay. So I'm the Director of Marketing at RISC-V, responsible for our events. We just had RISC-V Summit Europe last week, which was a great success. Also responsible for our website, content, that kind of thing. So yeah, talking about RISC-V, the ISET, and also the amazing things that happen in our ecosystem.
Thank you, Andy. Flo?
Hi everyone, I'm Flo. I'm the head of open hardware. I'm also a RISC-V ambassador because I think RISC-V is a great open standard. It really allows more freedom. At the open hardware, we are focusing on taking really good designs, which are open source, and then together with our members, which are industrial, but also academia, to bring these designs to a state where you can make real chips from them. So we are doing a lot of verification, making sure it's really top-notch. There are any hidden issues inside. And then our members are going and producing chips with a fully open source design based on the RISC-V standard. We're not only doing the RISC-V course, we are also doing other IPs, but this all is accelerating what we have available in the area of chip design. So I'm really excited to be here.
Thank you, Flo. Javier?
Hello, everybody. Thank you for inviting me. My name is Javier Serrano. I lead a team of hardware designers and low-level software developers at CERN, the European Laboratory for Particle Physics in Geneva. And I've been involved with open hardware since a long time, doing things like co-authoring the CERN Open Hardware License, co-creating the Open Hardware Repository, also contributing to the development of free and open source tools for hardware design like KiCad. And lately, I'm also part of the open source program office at CERN, So the CERN OSPO, we're very proud to say that it's one of the few OSPOs that supports people when they want to open source software and hardware equally. Thanks for having me.
Thank you, Javier. Luca?
Good afternoon, everybody. I'm Luca Benini. I'm a professor at ETH Zurich and at the University of Bologna. And since more than 1 decade, my group has been working on developing and releasing open source hardware, from processors to interconnect to accelerators, to enable what I'm really passionate about, which is silicon democratization, which means that everybody should be able to design their own chips. So we have been working on open source IP, but now we are also working on open source tools to design chips. And last but not least, we are also enabling open source chip manufacturing. So working with foundries that are willing to open source their information about their technology to make end-to-end open source chips possible.
Thank you very much. Well, as you can see, we have a very rich panel today. So we have an open standard that enables people design, and then we have an organization that helps to improve the quality or to provide more quality to designs, but also helping to continue the development. We have people that develop tools and IPs. We have people that develop also more IPs, but also helps and supports with the licensing. So we have a complete system here. Okay, probably, yeah, the background noise. Sorry for that. Probably it's also on my side. So just to provide some context before asking the first question, because we are talking about open source, and I think most of the people talk about it or have heard about it, because, well, it's like a commodity concept nowadays. Everybody is talking about open source, at least, well, not everybody, but in our circles, we have heard about open source. But I have the impression that most of the people usually relate open source with software and not with hardware. However, the ecosystem has to have both sides. I mean, has to contemplate software and hardware. And the idea of this webinar is also trying to explain and get in your point of view of the importance, the commonalities and differences between open source software, open source hardware, and the importance of it within the Europe. Although when we talk about open source, I mean, everything should be globally accessible, right? But how is the importance of that in Europe, and why should take care of it, and how to make it sustainable along the time? So that's some of the ideas that we want to discuss during the conversation. Starting with the first question, please jump in whenever you want, okay? It's not like you have to go in order, just whenever you want. The first question that I have, just to introduce the topic, is to each one of you. What does open source mean for you, okay? And then how your institution, organization contribute to it. Who wants to start?
I can start if nobody else is going. So, okay.
Go.
So open source hardware is very intuitively hardware for which the designs are available, guaranteeing the typical freedoms that one gets. People are used to having with free and open source software. So freedom to inspect, to study, to modify, to redistribute, modify designs. So all these things apply to hardware designs this time. And also we add the freedom to make hardware based on those designs and to commercialize the hardware. So that's open source hardware. I realized that most of the other speakers are dealing with integrated circuit design. So I'm here also to represent and to ensure that we consider that open hardware applies to any kind of hardware. It could be the design of a chair, it could be the design of a printed circuit board, scientific instrumentation, for example, very relevant to CERN as well. So any hardware for which the design can be shared, modified, redistributed, etc., and used as a basis for manufacturing. At CERN, we are concerned with open hardware extensively. We have two hats. We are sometimes a producer of open hardware and sometimes a consumer. As a producer, it's in our mandate to not only conduct research in fundamental physics, but also to share the developments that we carry out on the path to those discoveries. And it's also, I think, nice for hardware designers to be able to interact a bit like their software colleagues and to be able to learn and to collaborate with outside people without any risk of vendor lock-in. So that's us as producers. As consumers, we sometimes change hats and we want to purchase hardware. And for us, there are several reasons why open hardware is important. But just to summarize, one is the very long timelines of our accelerators that we run at CERN. So it is incompatible with vendor lock-in. But on the other hand, we cannot design everything ourselves. So we have found that open hardware is a very nice tool to actually avoid vendor lock-in without having to design everything in-house. And another reason why we embrace open hardware when we act as a consumer is that we are expected.
Javier, you got muted.
Sorry, I don't know when I got muted, but in any case, I was saying that with our consumer hat, we also try to buy from member states of CERN, or the states who participate in the running of CERN in the budget. So open hardware also allows us to have more flexibility in where we purchase from.
Yeah, I would be pleased to add on top of what Javier has described. And I would start from the distinction between open source hardware and open standard, because I think it's an important distinction. Though most of the values that Javier described are very much applicable to an open standard as well. But there's a key difference that is important. So I would like to start by explaining that RISC-V is an open industry standard. And usually we like to make the reference to the USB or the Wi-Fi or the internet protocols. So these are all open standards that are freely available on the website. In the previous professional life, I used to design USB devices. And so I used to download the USB specifications from the USB IF. Flo, I'm getting echo from you. So download the specifications, study them freely, and then wherever you are, invest locally in building your design. And RISC-V is the same. RISC-V is an open standard. So it describes the instruction set architecture. It describes how the hardware and software will work together on a RISC-V microprocessor. And this is freely available from our website. And these specifications are developed in a collaborative mode with all the members that are contributing to RISC-V. When we move from open standard to open hardware, the distinction, or to open source hardware, the distinction is the artifact. A standard is a PDF. This is what we do in the end. And an open source hardware is an artifact, is an implementation of the standard. And there can be multiple implementations compliant to the standard. Some can be open source hardware, which are very, very valuable. And some can be commercial and licensed under commercial license agreements, like an IP. Some can also be implementations for internal use only by a semiconductor vendor, for example. So that's the important distinction, that a standard can have multiple different implementations, and at RISC-V, we're happy to support all possible implementations, and we don't have one reference because we don't want to do any technology transfer. We want to comply with all regulations worldwide. And so staying at the standard is what makes us neutral internationally across all geographies. And this was recently certified or recognized by ISO IEC. The JTC one last September granted us the status of publicly available specification pass submitter, which means that they recognize our role as somewhat a standardization body. And the next step for us is to submit the RISC-V ESA manuals to hopefully be recognized, evaluated, hopefully ratified by ISO IEC as an industry standard. So I wanted to make this distinction between the standard and the multiple implementations.
Thanks for pointing out that, Andrea, because I think it's very important, because in this case, the standard is like an enabler, right, for doing whatever you want, and then the result might be open source.
Yes, and all the values mentioned by Javier, freedom from a single vendor lock-in, this also comes from the fact that the standard is public and open, because many implementations, but also many IP vendors, not only the silicon vendors, the semiconductors, but also the IP vendors can all play a multi-source strategy, because they know that the standards will not be locked down. So everything Javier stated works really well for an open standard as well.
Thank you. Luca, you raise your hand.
Yes, so maybe my viewpoint here. I come from an academic perspective. So as a professor, the first mandate of a university is to be able to perform relevant research and also be able to disseminate your research results. So, in the past, when you would design hardware, you will pretty much be stuck, because you could write a paper on the hardware you designed, but it was very difficult for others to take your research, use it as a starting point, or even reproduce your results, which is actually, one of the key mandates for open research today. So people should be able to take what you have done and then build upon it or reproduce it. And for hardware design, this was kind of impossible in the past. So that's why I started to think about how we can make research more available, more reproducible. And the obvious answer was we should release open source the hardware designs we make. And what was possible, like a decade ago when we started, was to release the source code of the hardware that you designed in form of a hardware description language files, similar to what you would release when you release software, open software, so that in form of artifacts, the artifact you release is files. So it's not so much different from software, but these files can be used by people that know how to design hardware as a starting point for using the design automation tools to actually design chips and simulate and compare and so on. So this was the first motivation to go into open hardware, more open and reproducible research. The second motivation came a bit with the serendipity, in the sense that having chosen a license that would allow companies to use this open hardware and make commercial products, and not even necessarily releasing their hardware as open source as well, we also had a lot of companies interested in using our open source hardware for their products, and or for industrial evolutions, or for industrial explorations like benchmarking and so on. And so this also created a huge motivation to work on open hardware, because now it makes it much easier for us to work with companies of all kinds in collaboration to actually, help the industry. And not only the global industry, but many startups And many of the local ecosystems are facilitated by having access to hardware that they can use for their own designs. So the second big step was to go toward this idea of using open hardware as an enabler for innovation. And the third step, which is the most recent, was if we can couple open hardware with open design automation tools, so tools that you don't have to pay very expensive licenses to use, but they are open source, and also open PDKs, in other words, foundries releasing the files needed to produce chips in their foundries, in releasing this information openly, then it is even possible to design a fully end-to-end open source chip. So without having to do anything in the secret. And this actually opens the way for things like auditable hardware where you can inspect everything from the design to the implementation, which could be extremely important for security certifications and similar issues. So now the third step is a fully end-to-end open source hardware, which is what we are working on right now.
It's really impressive, Flo.
That is actually amazing because the open hardware, so first off, we are a non-profit, we are based in Belgium. And the reason why we are existing is actually because what Luca just said, or what has been started at Luca's department, open source semiconductor description, mainly for the CPU core. So a lot of industry looked at it and said, well, we have always been bound to this commercial available things. We were not be able to modify it. We couldn't adjust it to our use case. We had to use the same like everyone else because there was only like one company who could license this, or maybe a few, but there was one dominant, still is. But with RISC-V, we have now the flexibility, and RISC-V is an open standard, so we can do much more faster. But why we don't have also open source RISC-V cores? And then they looked around and actually they came to Luca's group. There have been cool designs like the Ariane core. We are now calling it CVA6 at the open hardware, but it originated in ETH Pulp team. So the industry player said, that's a really good design. We would like to use it, but to make a chip and integrated circuit is still kind of expensive. And you cannot you cannot have any issue inside. So you really need to test it very, very well. But if everyone is doing the same on an open source chip, it doesn't make any sense. Everyone is putting a lot of resource in. Why we are not combining this resource and come together in a kind of consortia and do this verification and validation together, and then everyone can use this baseline, and based on the baseline, enhance, add new things. That's how the open hardware was founded in 2019. We are doing this now today. So for me, open source really means that it's not only open source available, but that you're also having a collaboration. So there are some open source where people work on, but there are only one company. Maybe I feel it is open source, yes. But the real benefit we are seeing, the real innovation comes when several companies come together. And what has been actually really, really helpful is to then bring this open source also in real products, to bring it to the market, to get active feedback, and then based on this, iterate, enhance the product. So for us, the open source, it was a great step to have the course open source, and now seeing all this value coming on top and even more researchers working on it now and having something where they say that is really going into mass production. And now we can do some tests. We want to know how the performance change if I adjust ABC or so. That is a really big benefit of open source. So collaboration, working together. And I'm really excited to also now have this end-to-end design Luca just mentioned coming that will bring it to more researchers, but also to hobbyists. And I think that will bring a lot of more innovation to the whole ecosystem and accelerate the state of new electronics coming really fast and rapidly. Andy.
So just a quick follow-up to some of the great points that have been made. I think one of the things we see, as RISC-V in terms of, in terms of open standard hardware and open source hardware, is the ability to, for the world, it's the nature of the worldwide collaboration, but also worldwide customization of what can happen. So people working together to create something that is useful for everyone, but also the ability to specialize for your specific application in your area. So I think it's a very powerful thing to be able to work together, but also specialize individually for applications. It creates some really interesting applications.
Actually, that reminds me of something that a colleague told me a couple of years ago. He said, well, the good thing of open hardware, and in this case also the openness standard, is that we can explore new solutions to all problems. We can rethink and try to find new ways of doing things, because now we have access and control on what we want to do. And moving in this direction, what do you think are the main differences between open source software with respect to open source hardware? I mean, it might be on the way the people has to contribute. It might be on, for sure, the licenses. So what are the commonalities and the differences from your point of view? Flo, you are unmuted. So
yeah. I think that is a really good question. Thinking about this hardware versus software, so there is really some good news. Hardware is just in the beginning. Sorry, Luca, I know you're doing it for decades, but what I'm trying to say is that bringing it to broader adoption, that is in the beginning. So sometimes we hear it as a problem where people say software is everywhere, there are a lot of contributors, and hardware, it's still a little bit a small community, but I see it changing rapidly, and I think that is actually a very good thing to have. So I only can invite everyone to join open source hardware because of the speed where we are seeing innovations. Luca's team just made a chip open source end to end, and it's all public, so you can recreate the process. You can change or add what you want. I know CERN is doing a lot of these things internally. What I'm also seeing is that this community is now rapidly growing because there are coming more advancements. There are coming this open PDKs. You can make your own things. And I think we also need this growing community, because compared to software, software is very mature. A lot of people are doing software. And especially from an industry point, what I'm seeing is we are still missing more people who are contributing and who are adding. It's still like hardware is complicated, it's difficult. Actually, I don't think so. It's very similar to software. We are using a few other terms, but it's really cool, and we are seeing people adapting open source hardware to build companies around it. There are several startups in Europe, in America, but actually all over the world, where people using open source hardware to build on it, open source semiconductor. So yeah, we're still, compared to software, a little bit behind, but we are catching up really rapidly. We need to catch up, so that's a little bit of concern, but that's also the good news, because you're still in the early stages for joining and can leave your footprint on it.
Andy, please.
And so the thing I just wanted to raise was, I think one of the things that we can also think about is, like, not necessarily thinking about hardware and software. With open hardware, one of the great things is that the hardware and the software are closer together than they have ever been. You can customize your hardware to suit your workload. And so I think, one of the things is probably visibility is an important thing. Lots of people know about open source software, but I think enabling people to consider that the hardware that they can use can be designed and configured in an open way, as well as the software is something that we're trying to do a better job of. So it's not just they're not these things that are necessarily completely separate, hardware and software, because of things like RISC-V and open hardware are closer together than ever.
Javier, please.
Yes, of course. Hardware, open source hardware wants to emulate the huge productivity gains and the very nice collaborative dynamics of free and open source software. Open source is mostly about reducing friction and making sure things can happen more seamlessly, more quickly. And there are a few reasons why hardware is different today, and there's a bit more friction. Having said that, things are going in the right direction, and there is still a lot of untapped space for improvement. One reason why we don't have such seamless collaborative dynamics could be the fact that many of the design tools are proprietary and the access to these tools is limited. So it's very nice to see that the European Commission and others are launching initiatives to palliate this problem, but definitely democratizing access to design tools and in particular making them free and open source is a very important step to get to those kind of software-like dynamics. The other thing, a fundamental limitation in hardware is that there are many things you can do collaboratively online, but ultimately most of the designs are meant to be built. So that is something that cannot be done effortlessly or without any cost. So that also imposes some fundamental limitation. But having said that, there is a lot we can do and put in place already to imitate the dynamics people have in software. One thing that we would need, if I now take the role of showing also that hardware is not only integrated circuits and digital integrated circuits, which typically these days is mostly code, so they can reproduce much of what's done for software easily. But if you're talking about schematics and diagrams and mechanical drawings, we don't have a GitHub for hardware, something that allows you to seamlessly introduce changes, make comments on a particular piece of a design, see the visual diffs, when you change a resistor, have a very easy visual cue of where you change things, and an easy way to collaborate and to contribute to designs. So, but basically, we have a roadmap, which is to look at software and try to emulate the success of free and open source software and all these nice dynamics in place.
And what can you tell me about the licenses? Because hardware and software are different, and so by nature, although they can, with open source hardware now, we can improve the collaboration and this co-design, hardware software co-design, because we can have access to both stacks. But the way that we can exploit and develop hardware is a little bit different. So and the nature is different per se. So what about the licenses? What kind of licenses, or what are the differences between the licenses is in software versus hardware?
Shall I? Yes. So, of course, one of the ingredients that we identified early on in our journey at CERN for open source hardware was the lack of a good set of licenses to share designs in a legally sound way, in particular with industry. Version 2 of the CERN Open Hardware License has been out since 2020, and we set ourselves to provide the community with a set of licenses that would cater for any kind of sharing, or the three typical sharing regimes that you see in free and open source software, namely permissive, weakly reciprocal, so LGPL-like, and strongly reciprocal like the GPL. Before that, there was no good options for sharing hardware designs in the reciprocal regimes. So we're very happy that we now have these two variants of the license for weakly reciprocal and strongly reciprocal sharing. And on the permissive side, people have been using, as Lucas said, software licenses, which, permissive is an easier realm to work in. It's a simpler problem to solve, permissive licensing. So software licenses like the Apache v2 and transpositions of that into a language that hardware designers can easily relate to, like SolderPad, work perfectly well, in my opinion. The CERN Open Hardware License permissive variant does the same job with a slight difference in the patent license. You know, when I publish something, I promise you that I will not sue you for patent infringement, but also if you sue me, then you lose all your rights. Well, in the case of the CERN Open Hardware License P variant, the permissive variant, you lose all your rights. In the case of Apache v2 and SolderPad, you lose only the patent rights. So that's a slight difference, a bit more teeth in the permissive variant of the CERN Open Hardware License. But otherwise, in the permissive realm, I think legal issues are largely solved. It was just in the reciprocal ones that we needed to put a bit more work in, and I'm happy to see that people are already using them in both for FPGA and IC design, but also beyond in the type of hardware you can drop on your foot.
What I think is really cool when you're having, like in open hardware, we are using a lot of the Apache v2 or the SolderPad, which is on top of Apache 2. And what is really cool to see is that companies who have been before very working in their own space, isolated by NDAs and really hard to share with a lot of the commercial IPs, are now able to bring this more to the public and go out. We have one project, it's kind of new, it's an AI accelerator. Of course, there are RISC-V cores inside, but the whole thing is based on the SolderPad version. So giving a clear, you can use it, you can make your own products. And that really allows the community to grow, so having a lot of feedback. We found it also very easy for companies to explain it because everyone uses software so much. So when you're saying, hey, that is the same like Apache, it just defines a few new definitions on top what you have in hardware. That really helps, especially legal teams, but also project management teams in big companies to adopt it, which then helps to bring this open source more in the community, and then also enable the community, also industrial players, to share back. Like we have some people who are coming to us and said, hey, we worked on your design and we made a product. So I say, cool. And I say, you're not angry? I said, no, it's open source anyway. Okay. We made some improvements. Can we contribute them? Yes, of course, it's open source. Then it's get better for everyone. Okay, we checked it because it's based on Apache. Our legal team understand it. We have an agreement for software, so we also can do this for hardware. So licenses are super important, and there are a lot of different ones.
And I see that there is a lot of interest in the audience about licenses. I see Javier answering the questions. Thank you. And one question regarding software and hardware. Do you think, actually you have mentioned, all of you have mentioned that perhaps the open source hardware is more immature than the software? Do you think that that also has implications with respect to on business side? I mean, people usually feel less reluctant on taking something from the open source software than the hardware, perhaps because they don't, or they have the feeling that the hardware is more immature or it's more insecure. Do you have that feeling, or what do you think about it? Javier, please, and then Luca.
Yes. So ultimately, I have a lot of respect for private actors. I'm paid with public money, which is also a big responsibility. But I have a lot of respect for people who risk their own money when they take a decision. So for me, the business model is something that I typically don't tell people what they should be doing. But it is true that they typically. There is a lot of confusion with open source, and this was also the case with open source software in the past. It is a fact that people, through basic economics, you cannot sell something which is not a scarce good. So when you try to figure out what is it that you're going to sell, you have to keep this in mind. There are many so-called open source companies that they provide things which are open source, but they sell something which is proprietary. Otherwise, they could not be able to sell it. If what you sell can be gotten for free independently, then you would not be able to sell it. So when you sell support, you're selling access to the brains of the people, which is a limited resource. And when you sell other things like high quality manufacturing, that's also a scarce resource. When you sell the fact that you can provide reassurance and guarantee, that's also a scarce resource. So there is a lot of confusion, but already from the days of free and open source software, and many people who figured out appropriate business models. So I have no doubt that people in the private sphere are already, many of them able to create successful businesses out of or based on open source hardware, and we will see even more in the future.
I think I also want to emphasize a bit the challenge of the business models, because one of the main differentiators between hardware and software is that making an end product with the hardware is unavoidable, much more expensive than making it with software. So if you are developing an app, just to give an example, then it may require some investment because you have to have all the software engineering, the support, and so on and so forth. But getting out with your first product is much less risky and expensive than going out with your first chip, which is an endeavor that in any case will cost several millions of dollars, even in the best case. So the problem is that there is a very significant amount of risk involved, and whenever you have to gather capital for a high risk endeavor, people will want to see clearly what is the value and the payoff that you can offer to your investors. So there are a few questions in, say, if you work on open hardware, how can you guarantee that your product will be valuable and you will make money out of it? Because anybody can take the open hardware and replicate your product. So there are a lot of these questions, right? And I also acknowledge that we should not be too idealistic or purists about open hardware, in the sense that one could make very well chips that are a mix of open and closed hardware. So you could, in a sense, build the infrastructure of your chip based on open hardware, and then put differentiating blocks in your chips that are not open, and they, provide the added value. So we need to understand that this is something that people have to discover, and make sure that investors will understand that there is some value. There are also other business models, for example, the service model, or there is you are working on open hardware, and then you provide value by customizing services, quality control improvement, and so on. But someone could say that this is a business model that don't scale, cannot make a large amount of money with this. So this is just to give you a couple of views on how people are scratching their heads and trying to find ways to make money out of open hardware, which is definitely not as simple as doing it with open software.
That's true. I mean, building software or even designing and developing, it takes time and involves a lot of stages and people. Andy, you wanted to say something.
Just a little point. I think following on from what Luca was saying, there are bits of open source hardware that are for specific jobs. So like the OpenTitan project, being a root of trust, and so there are these pieces of hardware, of open source hardware that do specific things, and there are experts coming together to to make sure that that's a great piece of hardware. OpenTitan being used in Chromebooks and data centers already. So I think, as Luca was saying, there's individual bits that you might want to do certain things, and you can find specific projects that are doing that.
It's actually a good point. And Flo, you wanted to say something too. You're mute.
Mute, sorry. I wanted to jump in on the business model, what Javier and also Luca said. There is certainly kind of a new field. That's why I'm also so excited. But there is also a certain difficulty to navigate it. Like, it is expensive to make a chip now. If you make everything open source, you need to spend the money. You should not have a backend. You need to be fast. Otherwise, someone else can do exactly the same. But there is still something we need to figure out. What I'm seeing is that there are also many new business opportunities. Like in open hardware, we are verifying these chips and or this IP to make the cores reliable and rugged. But then big companies are still used to have service where they call someone 24/7 and say, this core makes me problems, how can I do it? So multiple startups have already started offering the service based on open source hardware. They are adding also other design services. That is really interesting. And then what we are also seeing is that companies are not making everything open source. Like, we have a core and we know big companies working on it. They do a lot of work contributing to it. It's your core, Luca, the CVA6, the former Ariane. And they still say we contribute a lot. We make the baseline good, but we still have some enhancements. It's for speed or it's for a special function we need in our product to differentiate. And that one we will not make open source. And that is a valid model. So I personally think the baseline should be all open source so we can maintain and contribute it together. And then having something on top of this, like special function for your own advantage, in my personal opinion, that is absolutely fine. And I would like to pick up one question from the audience I have seen in the chat. There was a question, what about China? Are they using open source and they are only using it, or are they also contributing? At Open Hardware Foundation, we have actually seen both. So we have like one customer, they signed up as a member, they are paying member fees, and we don't know what they are doing. So I was talking to them and said, why are you doing this? And they said, we are happy about this. We are putting it into products. We don't want to contribute, but we want to acknowledge what you're doing and help you going. But then there are also other examples where we had, for example, compiler support to make sure this RISC-V course working out of the box with compilers. We had 2 or 3 institutions from China who said, yeah, we are working on this in general. We would like to contribute to your work on your RISC-V course because it has more practical touch and we just help you to get this open source. So what I'm seeing is there is help and support coming out of China also. The same is actually for almost every region. Just last week we talked with Brazil. There is also support coming from, but also from the Americas. And of course, a lot of support from Europe.
And in your opinion, yes, I will give you the floor, Andy, in a moment. So in your opinion, how good or bad Europe is contributing to the open source hardware ecosystem? And here, as Javier mentioned in the very beginning, we have several roles that we can play. We can play the role of users, the producers, the maintainers, collaborators. So how do you think Europe is doing here? And Andy, you first, because you raised your hand.
Thank you. So, I mean, it was just picking up on what Flo was just saying. You know, at RISC-V, we see our membership as basically a third from Asia, a third from Europe, and a third from America. So, you know, we see, and that also kind of goes through to our working group. So, I mean, obviously, as Andrea was saying, we're an open standard. We're not, you know, producing open hardware, but in terms of contributions, we see, that's one of the things that we find great about it, is we see membership worldwide and contribution worldwide, and we don't see one area out innovating or out contributing another.
Coming to your question, Teresa, I personally feel Europe is very strong in the open source hardware. I see, especially in the semiconductor area, a lot of contribution. Also, thanks a lot to the European Union enabling and encouraging this. I think it's very beneficial for the European Union because we are getting more IP out in the open. We're getting more IP in the production where people are getting encouraged to pick it up, to work on it. In general, I'm really happy. We see contributions from both industrial and academic. We also see a good interaction between these groups where there are new innovations going into production, things from academia. So I think Europe is on a good way. We also see traction in America, but in America, I personally feel it's very business oriented. So there need to be a really solid business case. Where in Europe, I feel there is a little bit more where people say not necessarily there must be always a business case, but not necessarily so hard, where people also say, I need to understand this topic a little more, like RISC-V. Let's collaborate on the open hardware, for example. Let's test it. Let's interact with the community and also contribute if we find a bug or if we enhance a feature. Let's contribute this and then see how we get business. So I think from what I'm seeing, at least in our area, Europe is really one of the top contributors there.
My fear here with Europe is that it's true that perhaps our mindset is more on research and innovation, so we open and we produce a lot of content. My fear here is about the maintenance or the sustainability of those trails a long time, because we are sometimes based on PhD students' activities, and then the senior people has to continue pushing in that direction, but then we don't have people interested in the topic, and then it's abandoned. So there are many valuable pieces there, but we cannot have this strength or the power and say the human power just to continue those works. So it's like, and sometimes they are blurry, and then in the end we forget about those, and I think we lack some opportunities there. I don't know if that's my perception in here. But Javier, you wanted to say something, please.
Just picking up on the point you just raised, Teresa, I think we need to look at companies, commercial companies. If I look at the success of free and open source software, a lot of the contributors of the Linux kernel are paid by companies because these companies commercialize things that rely on that Linux kernel. So if everything is in place for that business model, then we have to explore it and see if companies can find the economic incentive to participate in the maintenance of the infrastructure, the basic infrastructure. I just wanted to go to your question on Europe, and I want to say something before I forget. In public institutions, Luca already explained many of the reasons why we open source things. Another reason that I forgot to mention is that we shouldn't be competing with the private sector, and this is a very efficient way of ensuring that you don't compete with anybody. There are two ways. One is to do things which are irrelevant, not to publish anything, or publish things which are not deemed useful by anybody. And the other way is, if I don't want to compete with anybody, is to open source. The very efficient way of making sure that I don't compete with anybody in the private sector who is paying the taxes that pay for my salary, which would be a problematic situation, of course. In terms of Europe, I think we should explore more, taking the recent publication of the open source strategy in the European Commission. I would say move beyond the public money, public code motto and extend it to hardware designs, even going beyond integrated circuits. I think there's quite a lot of momentum for integrated circuits, but if we're talking about sovereignty, I think we also want to be sovereign, to be able to build our own data centers, for example. And I am not aware of any vendor in Europe that designs and manufactures the high-end servers that we have in our data centers. And that is just one example. I could also talk about the production of clean energy and many others. So I think we should explore more these partnerships between public institutions open sourcing what they do, private companies adding their secret sauce and commercializing the results with more margin because they are allowed to customize in a proprietary way. This business model, which has proven its worth in many other areas, I think we should extend it to hardware. Sorry.
That's great. Thank you, because it's true that we usually are very focused on our bubbles, let's say, on our areas of expertise, and we forget that there's a whole world around it and that can reuse, and we can collaborate together to create something bigger, right? We have 4 minutes, and we prepare a Mentimeter just to make people in the audience participate, although they have been very active already in the chat, so thank you very much. We have 2 questions. So let's see. It works. Yes. So the idea here is that people scan this and they will get access to questions, and they can write their answers. So we have an interactive way. So let's see. 7 people join already. Great. Well, but at least we can go with 8, because otherwise we are gonna finish the. So that here the point is, how can open source be used in a, I don't know if in a better way, or, and I think Javier said some comments about this already, but I would like to hear from the audience. So please share your thoughts with us. Don't be shy. Oh, well, that's a good point. Yeah, but at least from the research perspective, sometimes we are very, very excited about our work, that we don't look for the end application and we start jumping just directly on the topic. So that's a good point. Okay, an ISO. Okay. Somebody else. Well, our speakers, do they want to say something to comment on this?
It's good to have a standard. I'm not sure if ISO is so. I mean, we are working on this in RISC-V. That is great to come. I fully understand the one with the commercial application, and I think that's a good point. It's coming to what Javier said before. If no one can earn money from it, difficult.
Sure. Okay. Creating open source hardware starting from the end users, communities, practices. I think some of the organizations that we have here in the call can help also with the best practices. So that could be a point, and all of them let people join and explore. So that's good. Incentive for long-term maintenance. Yeah, that's something that we mentioned before, that perhaps it's a business model that we could, incorporate in open source hardware, replicating the open source software model. Reference designs more. I think here there are some already, like CVA 6, for example, right now again, this is digital design, but that's the field I'm working on and I'm familiar with. But I think nowadays there is start being some reference models in that way. But we need to know more about those. And just to finalize, how can Europe do better to promote reliable open source hardware? And we have 1 minute, because then I don't want to retain here our speakers for longer. If not, we can leave it here and we can meeting another having another opportunity to meet and answering this question and other questions, because I had more here and we didn't have time to cover those. But thank you very much to everyone for joining us. special thanks to our speakers for their time and sharing with us the insights. And hopefully we we have to have a second part. Let's see if our speakers agree. That would be awesome. So thank you very much to everyone for your time, and hope to see you soon.
Thank you, everybody.
Thank you.
Thank you.
Thank you.
Bye-bye.
Bye.